The birthplace of stars, nebulas. Stars form in vast clouds of gas and dust known as nebulas. These clouds are primarily composed of hydrogen, the most abundant element in the universe. When regions of the nebula experience increased density, gravity begins to pull the gas and dust particles together, initiating the star formation process. Gravitational collapse and condensation. In certain parts of the nebula, regions of higher density begin to collapse under their own gravity. As the gas and dust collapse inward, they heat up, forming a dense core. This process, called gravitational collapse, is the initial step in the birth of a star. The formation of protostars. As the collapsing material gathers at the center, it forms a protostar, a young star that is still in the early stages of development. During this phase, the protostar is not yet hot enough to ignite nuclear fusion but continues to heat up as matter falls onto it, increasing its temperature and pressure. Nuclear fusion begins. Once the temperature and pressure in the core of the protostar become sufficiently high, nuclear fusion begins. This process involves the fusion of hydrogen atoms into helium, releasing vast amounts of energy. The onset of nuclear fusion marks the birth of a true star, capable of emitting light and heat. The role of stellar winds. As nuclear fusion powers the star, it generates powerful stellar winds, streams of charged particles that flow outward from the star. These winds help clear out any remaining gas and dust from the surrounding area, leaving behind a newly formed star surrounded by a nebula, which can eventually dissipate. The stellar life cycle and evolution. The new star enters the main sequence phase of its life cycle, where it remains for most of its life. During this phase, it steadily burns hydrogen in its core, producing light and heat. Over time, the star will evolve, expanding into a red giant or supergiant, depending on its mass, and eventually ending its life in a supernova or as a white dwarf. Types of nebulas involved in star formation. There are several types of nebulas that play a role in star formation. The most common are emission nebulas, which glow due to ionized gas, and molecular clouds, which are cold and dense, providing the ideal conditions for the collapse of gas and dust into new stars. Triggering star formation with shocks. Sometimes, nearby events like supernova explosions or collisions between nebulas can trigger star formation. These events send shock waves through the nebula, compressing the gas and dust and sparking the gravitational collapse necessary to form new stars. The lifespan of nebulas and star formation. Nebulas are not static, they evolve over millions of years. The process of star formation within a nebula takes a long time, often millions of years. Once stars have formed, their energy and stellar winds can disperse the surrounding gas and dust, leading to the eventual dissipation of the nebula. The role of nebulas in the universe's evolution. Nebulas are fundamental to the life cycle of stars and play a crucial role in the evolution of galaxies. Through star formation, nebulas contribute to the creation of new elements and the ongoing development of the universe, making them essential building blocks in cosmic evolution.